All right, in this video, we're going to talk about Unit 1, Lesson 2. So pause this video and look for these notes in your packet. Okay, hopefully you came back and you are ready to go. So we're going to go through this pretty quickly. If you need to, if I'm going too fast, just repeat it, replay it. But I'm going to go through every example here for Lesson 2. So we're going to talk about parabolas. We already talked about parabolas in the previous lesson, but in this one, we're going to talk about different orientations that the parabola can go and what the function would go to that specific parabola. So two things that we need to talk about to get us caught up is your focus. So there's a focus and there's a directrix that we didn't talk about originally with parabolas. And the focus is, I think about as the point where the parabola is kind of wrapping around. It is focused around that point. So this point here is the focus. The directrix is on the opposite side of it, and it's directly across from your parabola. And the directrix should never touch the parabola. Okay. You can have a vertical directrix or a horizontal directrix, but pretty much that'll tell you if your parabola is going to go sideways or if it's going to go up and down. Okay. So just like I was saying right before this, there are 4 orientations, up and down like we've been used to, right? And you actually have 2 other directions, so it's left and right. We're really familiar, hopefully by now, with the up and down movements or up and down orientations, but we're going to talk about the ones that go left and right as well. In these 2 examples, so we're going to go through 4 examples. We're going to identify every component of your parabola. We're going to identify the vertex, the directrix, the focus, p-value, which will help us later with focus, and something that we call the focal diameter length. In the videos I posted on the subplans, the videos, the people, they say, or they talk about lattice rectum. That's just another name for the focal diameter. So I'm just going to say focal diameter for the rest of the video, but know that that just means lattice rectum, and it's the same thing that the other people in the other videos are talking about. All right? So I'm going to graph these 2 things that they gave us, the vertex and the directrix, and let's see how we can get the focus and the p-value from that information. So the vertex is going to be at 0, 0, which is the origin, and your directrix is going to be x equals -3. X equals -3 is a vertical line, so I'm going to find where x equals -3, and I'm going to draw a vertical line straight down. Now I know my focus is on the other side of the vertex. So this is the vertex. This is my directrix. I know it's on the other side of my vertex. So the focus is going to be the same distance from the directrix and the vertex. So if the directrix is 3 spaces away from the vertex, I'll go 3 spaces away to find where my focus is. So this is going to be my focus. Right? F for focus. So that coordinate would be 3, 0. And that distance, like we talked about, this distance from the directrix to the vertex, or even the vertex to the focus, they should be the same number. That distance is p. So as a quick note, p is the distance from your directrix to your vertex. Or it can be your vertex to your focus. Okay. I'm writing up just initial because I don't have enough room, but V for vertex, D for directrix, F for focus. Okay. Focal diameter, or the lattice rectum, that is going to be a formula. It's going to be 4p. So whatever we have, now that we have 4p, we can find this focal diameter. And I'll show you how we use that. But first, focal diameter will be 4 times p, which is in this case 3. So your focal diameter is 12. Now, focal diameter is pretty much how wide your parabola is going to be. So this parabola is going to be 12 units wide. Parabolas are symmetrical. So along my focus, this is how I figure out how wide it's going to be. Right? So I want it to be symmetrical. I want it to be 12 evenly. Okay? So it's going to be 6 on each side. So 6 this way and 6 this way. Right? And that's where I'm going to place my points to see how wide my parabola is. So if I connected these points, the points for the focal diameter and my vertex, that gives me my parabola. It's a very wide parabola. Okay, let's do another example to try to focus in on some of these details. So again, vertex is 0, 0. So I'm going to plot that. Focus is 0, 3. Now this time they gave us focus. So focus at 0, 3, which is up here. Okay. I'm going to label that as my F for focus, V for vertex, and I want my directrix. So again, it is on the opposite side of the focus. So if focus is up here, I'm going to go directly across from it, and my directrix will be the same distance away, but just on the other side of the vertex. So this time, it's actually a vertical or a horizontal line. Horizontal. I know my graph is going to somehow wrap around the focus. I don't know how wide yet. I didn't solve the rest of the equation, but since my focus is up here, my parabola will wrap around that focus. It's focused around that point. So it'll look something like that by the end of it. Right, that directrix, that is a horizontal line. Horizontal lines are y equals, and this is y equals -3. P-value is the distance between the diameter and vertex, or vertex and focus. Therefore, in our case here, the p-value is again 3. Focal diameter, 4p, which means that is 4 times 3, leaving us with the focal diameter of, again, 12. So focal diameter always along the focus, and I'm going to count 12 spaces, 6 on each side. We want it to be even on both sides of this parabola. So 6 this way and 6 the other way. So those points that I got from the focal diameter and my vertex, those give us the 3 points that we need to create our parabola. Right, 2 more examples. Pretty much the same thing. I'm going to go through it a little bit quicker just so you can see another example. Okay. Focus, -4, 0. So it'd be -4, 0 here. My directrix is at x equals 2, right here. D for directrix, F for focus, and I'm missing my vertex. So that's actually right in the middle between these two things, focus and directrix. So that would be here, 3 spaces from both the focus and directrix, and I'm going to label that as a V. And the focus would be, or the vertex would be at -1, 0. P, the distance from D to V, or V to F, that is 3 spaces again here. So our focal diameter is still the same so far with 12. So along my focus, I'm going to go 6 up and 6 down so that I get a symmetrical parabola like that. Last one on this page, I have vertex at 0, -1. Directrix at y equals 1, so a horizontal line at 1. D for directrix. And my focus, again, focus directly across from the directrix. So it's going to be 2 spaces down from the vertex. And that's my F value. Okay, so focus this time is going to be on 0, -3. P value, the distance between D to V or V to F. This time it's not 3 anymore. This time, if we count it, it's actually 2. 2 spaces. So P is 2, meaning our focal diameter, 4 times 2, is going to give us 8. Spreading 8 evenly out to both sides, I will go 4 to the left and 4 to the right. Did I do that right? 4 to the left and 4 to the right. There you go. So that's where I'm going to put my points. So using these 3 points, I create my parabola. All right, so replay that video if you need to, go over any of these topics, but you're going to see a part 2 where we go to the second part of lesson 2. See you guys there.